Today, I just could proceed to discuss the lipid. So, what is the lipid is all about, and I will discuss on the syllabus of Dibrugarh University that is presently in the sixth semester, where it is classifications is there. Common structure of the fatty acids have to be studied. Triglycerides and the phosphoglycerides have to be studied. Change of flavor of oil, reversions and rancidity, saponifications, what is the saponifications value, iodine number, etc. have to be discussed here. So right now, what are the lipids? So lipids are actually macromolecules made of fatty acids. Fatty acids means carboxylic acids. Long chains carboxylic acids are called fatty acids. So fatty acids monomer. Function of lipids including structural support for the cell, energy storage, cell signaling, etc. So lipids are non-polar in nature and do not interact with water. So what are the main types of solids? If we find out, then these are the triglycerides and phosphoglycerides. Even steroids and wax are also part of the lipids. So we have to go through the detailed discussions on triglycerides and phospholipids or glycerides here only. Next, introduction. So lipids are compounds of biological origins that dissolve in non-polar solvents such as chloroform, diethyl ether, etc. So lipids are defined by the physical operations used to isolate them, and they include a variety of structural types represented by the following examples. For reference, you just go for the Solomon book. Next, it is the lipid. Lipids are actually can be divided into three parts. Say one, a structure of lipids as a human being, where the chlorine acts as a head and the phosphate look like its eyes and glycerols look like its mouth and nose, and rest is the two legs as edges. Here will be many, but we will go through only a few. So what are the lipids? So basically lipids are organic compounds found in living organisms, soluble in non-polar organic solvents, and each compound can be classified on the basis of physical property rather than the structure. So lipids have a variety of structures and functions. For example, there are solubility of the lipids in non-polar organic solvent only, that is the significant hydrocarbon component. Hydrocarbon portions is responsible for the oiliness or fattiness associated with the lipids. The lipid word comes from the Greek word lipons, means fat. So some commonly used fatty acids present in our body are as follows. So fatty acids are long chain carboxylic acids, as I have already mentioned, or else already you have known. So number of carbon can be saturated or can be unsaturated. So common name, lauric acid, myristic acids, etc., stearic acids, etc. But its systematic name in terms of UPAC procedure, dodecanoic acid. That means so hope you can draw the structure. That's why I just left it out vacant. Then it is a tetradecanoic acid. Deca means 10. So if it is tetra, that means it will have 4 carbon more. So here similarly, hexa means 16, octa means 18, and dodeca means 12 only, 12 carbon. So here, here I am showing the difference of the oils and fats. What are the differences between the oils and fats? On the basis of difference, I can teach you better way. I can present you a better way to view the fats and oils and fats. So oils means these give fatty acids and glycerols on hydrolysis. So oils are those which give fatty acids and glycerol. Remember, oil on hydrolysis always give fatty acids. That means carboxylic acid and the glycerol. Fats are those they give fatty acids and glycerol on hydrolysis. That means this point remains same both for the oils and the fats. So when we consider the oil, it is the liquid. At ordinary temperature, oils will behave as a liquid substance, but fats behaves as a solid substance. So these are because of saturated fatty acids, and if it is oil, then it is the unsaturated fatty acids. Okay. Point number 3, those obtained from vegetable origins are oils. That means coconut, groundnut oil, cotton oil, etc. are the part of the oil. Okay, so these are the simple oil. Butter, lard, beef, tallow, etc. are the animal origins, and they are considered as the fats. And as you know, these are all are solids. So all the solids means fats, while oils means liquids. So let's go through the details of the structure, property, and the biological importance of triglycerides and the phosphoglycerides. So here, if you observed, here it is here it is the esteric part. So this one is ester, this one is ester, this one is also an esteric part. Okay, these three are, if it is in the third esteric group, if it is replaced by phosphate group or phosphate ester, then it is called phosphoglycerides. So triglycerides means ester of glycerol, while phosphoglycerides means there is a presence of phosphate linkage from phosphate linkage or phosphate ester of glycerol. So here this is the two examples. Next, if you look out the structure, how it can be. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that means here it is 17 number of carbon. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That means both are containing same number of carbon. So here it's a saturated, since there is no presence of double bond. So that means saturated fatty acids. Here it is a presence of double bonds. So that means it will behave as a unsaturated fatty acids. So here it is the ester group 1, here it is the group 2, and here it is the group 3, where it is linkage to the phosphate 1. If it is linkage to a phosphate group, then it is called phospholipids. These particular portions is always behaves as a hydrophilic. That means it will attract towards the water, while hydrophobic part always repel the water. So here it is the phosphate linkage, here it is the glycerol. So it will be exist in our living beings as shown below, as shown above. So phospholipids, bilayer, where it is the two layer, that is the hydrophobic, this is the hydrophilic. So this is the way to. Next topic is our change of flavor of oil. Flavor of oil either by reversions or rancidity. So if it is reversions, there is a change in edible fats characterized by the development of an objectionable flavor prior to the true rancidity. In refined oil, fat is known as flavor of reversions. Okay, and the term rancid is applied to any oil or fat that develops disagreeable odor due to its slow decompositions, either by air or due to some other reasons, into lower acids, is called rancidity. The reversions may be developed due to the exposure of fat to ultraviolet or visible light or by heating. Presence of oxygen is necessary to carry out the reversions. The catalysts which are usually effective are copper and iron. Rancidity is a reaction responsible and for example hydrolysis and oxidations. Hydrolysis is the hydrolytic, oxidation is the oxidative. Leads to a typical flavor of rancid oil. While in case of reversion, flavor chains develop before onset of rancidity with very little of oxidation. So there is no that much of the reactions like pattern for the reversions, and only some oil reverts. For example, soya or bean oil, fish oil, linseed oil, and the high portions of unsaturated fatty acids can undergo reversions. Well, rancidity can be observed in the sunflower, mustard oil, maize oil, groundnut, etc. So what is the hydrolytic rancidity and the oxidative rancidity? We have already discussed that there are two. So what are the two? Here is water this is the ester linkage which on hydrolysis gives an alcohol followed by an carboxylic acid. So carboxylic acid is a fatty acid. So hydrolytic rancidity means simply hydrolysis. Okay, so hydrolysis is just examples of hydrolytic rancidity. But oxidative rancidity due to the oxidation of fatty acid, typically by the addition of oxygen across the carbon-carbon double bond in unsaturated fatty acid, etc. So hydrolytic rancidity commonly occurred in presence of enzyme, for example, lipids, heat and moisture, etc., etc. While oxidative will be carried out by the free radical mechanism catalyzed by the light in presence of enzyme or the metal ion. And hydrolytic rancidity, water present in food and the high temperature will increase the rate of hydrolysis of fatty acids. While in oxidative, the complex free radical reactions will produce a wide variety of products, many of which have unpleasant odor or taste. In hydrolytic rancidity, the free fatty acids have an unpleasant smell, giving a rancid smell and a taste to the milk and butter that have been stored for too long. And in oxidative rancidity, it's highly unsaturated lipids only. So you just go through that. There may be some questions of distinguish hydrolytic rancidity, oxidative rancidity, even it is commonly called as auto-oxidations. So such types may be. So let's discuss about some of the earlier questions based from the Dibrugarh University papers. So these are, I just find out the following questions. What is the rancidity? Already we have discussed that rancidity is all about the decompositions of oil through air due to the air, heat, etc., etc. So reactions responsible are hydrolysis and oxidations. Hydrolytic oxidative, like as oil, can turn rancid, maize, groundnut oil, etc. How can we prevent the rancidity? By applying antioxidant, for example, ascorbic acid or vitamin C, vitamin E, hydroquinone, gallic acid, its ester, 3 tertiary butyl 4-hydroxyanisole, which is commonly applied to the potato chips. Secondly, by improving the condition of storage. For example, if we store at the refrigerator temperature by colored refrigerator temperature, it can be can be a cause of prevention of rancidity due to the lower temperature. Similarly, by colored glass container, which disallow the activity of the rays of light responsible to catalyze the oxidations of fats. Green bottles, wrappers, yellow transparent cellophane wrappers are effectively used to prevent the rancidity. By vacuum packing, even in vacuum packing, can lead to the prevention of rancidity. Next question is that what are the function of triglycerides? Already we know that the esters of glycerol is called triglycerides. So biological function of triglycerides is that triglycerides are primarily used as an energy reserve for animal. When they metabolize, they yield more than twice the amount of energy per gram that carbohydrates do. And on point number 2, fats are form of long-term energy storage, whereas carbohydrates are the source of rapid release of energy. So due to the fat only, we can store our energy. Now, the next question is that what are the phosphoglycerides? Mention their biological importance. Or similarly, some other questions may be, what are the phospholipids? Give an example of phospholipids with structure. So as we have already discussed, this phospholipids or lipids are the just examples of phosphate, presence of phosphate group in a triglyceride. So here it is a phosphate group, then this is the particular group. There are the two groups present. One is here, another one is here. Whichever users can apply, users apply. If it is RECH3, then it is called the phosphatidylcholine. Very difficulty in pronouncing all about. So what is the saponification value of a fat? What is the significance determining the quality of lipid? So what is the saponification value? Saponification value is that the alkaline hydrolysis of fats or oil is called saponification, because one of the product of hydrolysis is soap, sodium or potassium salt of higher fatty acids. Here it is the triglycerides. When it will react with sodium hydroxides, it will give the glycerol and the soap. So how much soaps has been produced is called the saponification. Where saponification value is inversely proportional to the molecular mass, or molecular mass is inversely proportional to saponification value. Or simply, saponification value is inversely proportional to chain length. After experimenting a lot, we just find out that the saponification value inversely proportional to chain length, and similarly, its saponification value is directly proportional to short chain length. Higher the length of the carbon, saponification value will be lower. So that means it will be based on the molecular mass. So next one is, what are the bad fats and which food contain them? So bad foods means which include trans fats, saturated fats, cholesterol, etc. are the bad are considered as the bad fat. While good fats, that means which will not have any trans fat, and fat should be unsaturated and lower total cholesterol. So what are the foods that contains the high amount of good food? So if it is, we consider saturated fats, animal fats, cholesterol, say seafoods, meats, etc. will be considered as the. So these are some of the healthy fats. So all the healthy fats should be considered as the good fat, and these are the unhealthy fats. I just have to reverse it out. So here it should be for the healthy one. Bad fats should be for the unhealthy fats. Let's go to the next slide. How do you isolate carboxylic acids and alcohols from fats and oil? So how can I isolate? So just I have to carry out the hydrolysis. Hydrolysis of any triglycerides or any phospholipid. Triglycerides will lead to form glycerol and fatty acids. So this is the way. Next, what is the hydrogenation of oil? What is importance in lipidity? So due to the unsaturations, it exists as a bad fat. Of when we hydrogenated it, it will turn to a saturated fat, which is good for us. So this is the way to prepare oils in many industrial purpose. What is the next one is that what is the iodine value or iodine number? Just like our earlier slide, that is the saponifications value, iodine value also an important part to determine the various structural and various properties of fatty of lipids. On the basis of iodine value, we can find out whether the oil is good for health or not. For example, if it is olive oil is 82, cottonseed oil is around 109 on the iodine value index. That means cottonseed oil should not be good compared to the olive oil, which is nearly 82 only. So that means number of grams of iodine or equivalent like ICl, iodine chloride, that will add to 100 grams of fats or oil. When it reacts, that means there is a presence of unsaturated double bond